Welcome back to your Algebra 1 Semester 1 final review. We're looking at a piecewise function here. Now, one thing students often get confused by is the difference between a piecewise function versus a system of inequalities. Now I'm just going to show you a quick example, and this is a side note for this problem, so if you know the difference you can skip ahead or so, but it's probably worthwhile looking at. A piecewise function is really just one equation that's made by multiple pieces of smaller equations. So I'm just rewriting A down here. There's no shading involved with piecewise functions. All this is really showing us here is that we're going to use a piece of one equation and a piece of another equation, which is why we have two different lines that are small pieces on our graph. However, a system of inequalities might look something like this. They might say y is less than 2x minus 3 and y is greater than or equal to 3x minus 5. These are full lines on here. These ones we would have one line that goes forever, we would have another line that goes forever, and then there would be some shading on here as well. So this inequality, the system of inequalities, won't have these little semicolons, and they'll just have one equal sign, and this one really has two different equal signs, two different y's. So make sure you practice keeping those straight. We are just looking at a piecewise function here. So what we're going to do is look at two different ways we could have figured out the answer. The first way is we're just going to reverse engineer the problem. We're going to start with the graph and figure out the equations. And then the second way is we're going to look at all the equations over here and see if we can figure out by process of elimination which one matches. But first, let's build our equation. There are two different lines here, and I'm going to label them as line 1 and line 2. A piecewise function is just going to have y equals, and then we're going to have two different branches here. One of them is going to go with equation 1, and one will go with equation 2. How do we build those? Well, as long as there's a nice y-intercept for each equation, we should probably just use slope-intercept form, y equals mx plus b. And I see a really nice y-intercept on my first equation. The second equation looks trickier though because it never crosses the y-axis. However, we could put in that little phantom part that would cross just by using the slope. Notice that if we pick some nice points on here, we're going down 3 over 1. So continue the pattern. Down 1, 2, 3 over 1 will show us that if this equation had continued, it would cross the y-axis at -5. So now we can build our equation. Y-intercept of the first one is looking like +3. The y-intercept of the second one is -5. But don't forget, for an mx plus b equation, we need a slope and a y-intercept. Let's at least put in the y-intercepts. First equation, y-intercept of +3. Second equation, y-intercept of -5. Slopes, we already even talked about the slope of the second one. We said it goes down 3 to the left 1. But if you're not sure about the sign of this, we know it's down 3 left 1. If you're not sure about a negative versus positive, just think about this line. This line is going in an upwards direction from left to right. This is a positive slope. The reason it's a positive slope is because we have a negative divided by a negative. That makes a positive. So I'm going to keep this positive slope right here, and then we look at the purple one. The purple one is also going in an upwards direction. It also has a positive slope. What is the slope? Well, it looks like we go up 2 over 1. Now, we have our two equations. That's nothing too terrible. The last part, though, is cutting off pieces of the equation. And the way we cut off pieces of the equation, I'm going to erase this for some clarity, is we decide what is the x value where we jump from one equation to the other. And we should see that these two equations split right here. If you think of this as an invisible wall, to the left of the invisible wall, there's equation 1. To the right of the invisible wall, there's equation 2. Where is the invisible wall? Well, it's at an x value of +1. So then from here, we just need to describe the left side over here versus the right side. The left side, the part that has equation 1, notice these x's down here on the x-axis since we used an x. All the x's here are numbers that are smaller than 1. 0, -1, -2, all that stuff. So the way we show that the x's are smaller than 1 is we say that x's are smaller. We use that less than sign than 1. On the right side of 1, we look at the x's and we see 2, 3, 4, 5. Those are all x's that are larger than 1. And now we can go through and describe these equations. We used equation 2 for x's that were larger than 1. We used equation 1 for x's that were less than 1. And then right at the wall, which equation did we use for x being equal to 1? Well, we need to remember that a closed circle is equal and an open circle is not equal. So the part that was equal at x equals 1 was this closed circle on equation 1. And so the way we show that equation 1 was equal is we put a little equal sign underneath. And now we've created our equations. Looking at that, I bet we can go back and determine which is the right answer choice. To me, it's looking like it's got to be B. But I promised you a second way, a process of elimination, so let's look at that as well. First thing you should notice is the slopes. However, the slopes are the same every time, so that doesn't really help us. The next thing we should realize is that we can see the y-intercepts. All of these are in mx plus b form, so let's look at the two y-intercepts. On A, we have y-intercepts of -3 and -5. Well, this is +3 though, so because that's +3 instead of negative, A is out. And D is out as well, -3 and -5. So then, last but not least, we're down to B and C, and you'll notice they're all exactly the same except for one has a less than and one has a greater than. So we need to go and maybe sketch a quick wall at 1, which is what I did over here. I'm going to get rid of all this extra stuff. Here is my wall that's at 1. And then we need to see, well, did we use this equation to the left side of the wall or to the right? Now don't forget that less than is going to be to the left of the wall, greater than is going to be to the right. And you'll notice on this equation over here, 2x plus 3, which we said was this line, let's keep my colors consistent, which we said was this line is to the left of the wall, right? 2x plus 3 is to the left of my wall at x equals 1. To the left of the wall is going to be a less than sign, and so it has to be B.